In this lesson, we're going to talk about slope, which is also called rate of change. Below here, I have 4 examples of 4 different types of slopes. You can see the one on the far left is called a positive slope. You can see that the biker is running uphill, going from the left side of the graph to the right side of the graph. This signifies that the slope of this line is a positive number. The next one is the negative slope. You can see that the biker is going downhill, starting at the left side of the graph and moving to the right. So this indicates that this will be a negative slope. Okay, now we're going to look at 2 unique types of slopes. These are zero and undefined. These are oftentimes, can be easy to confuse with one another. The first one is a zero slope. So if a line has a slope of 0, it means that it's just a horizontal line moving from the left side to the right side, going in both directions. And the best way I like to remember it is if you think about walking on a treadmill and your incline is at 0, you're walking flat on the treadmill. And the last one here is an undefined slope. And if you look here, our biker is, is riding his bike from down the line. That's a vertical line. And you can see that it is undefined what's going to happen to this biker once he rides down this slope. Okay, the variable that we use to identify the slope is m. Okay, let's go ahead and look at some lines and talk about slope here. Okay, our first example, we're given this linear equation. And we don't know what the equation is, but we're trying to determine what is the slope of this line. So what is a numerical number that is representing the slope of this line? Here's how you find the slope. So I'm going to identify one of the points on my coordinate plane. I usually like to start with the one that's closest to the left side of my coordinate grid. And what I'm going to do is this little thing called rise over run. My goal is to get to this point over on the right-hand side. And I have to get there kind of like if you think about, I don't know if you've ever heard of the little Pac-Man guy. He can only move up, down, left, and right. He can't move diagonally. So I'm going to move from the point on the left. I'm going to move, I'm going to rise and I'm going to run to get to that new destination. So I'm going to rise, and I have to rise 1, and I have to run 1, 2, 3, 4, 5, 6. So my rise was 1 and my run was 6. And therefore, my slope, which is represented by m, is going to be 1/6. Okay, let's look at the other one. This is a positive slope. You can see that the line is going upward, just like the previous one. And if we look at, let's go ahead and choose this point right here. I need to make it from here to my final destination. So I need to rise, and it looks like my rise is going to be 2. And my run is going to be 1, meaning I'm rising up, which is positive, and I'm running to the right, which is positive as well. So if I divide that, 2 divided by 1, that's going to give me a slope of 2. So my slope of this line is going to be 2. Okay, now let's look at negative slopes. It works the exact same way, but we now need to be really careful about which direction we're moving. So let's go ahead and let's start at this point right here. I need to make it to my final destination, and this time I'm going to rise -3. Notice how I went down, which gives me a -3 of a rise. And I'm going to move to the right, which is a positive number, 4 times. So my slope in our case is going to be -3/4. You'll see that because my line is slanted downward like this, my number should be negative. Now, you may be wondering, what if I went the other direction? Meaning, what? Let me go ahead and erase this real quick. And let me show you, you might have this question in the back of your head, so I wanted to show you. So what happens if I want to start at this point and I want to go up to this point? Well, it works the same way. I'm going to go ahead and rise. I'm going to rise 3 in my case, so I'm going to write a 3. And then I'm going to run -4. You'll notice that these 2 answers are identical. And therefore, no matter which way you go, from the left point to the right or to the right to the left, it doesn't matter, your slope will be the same. Okay, let's look at one more. All right, I'm going to go ahead. I'm going to start from this point this time. You can start at the other point, and we can meet in the middle. So I'm going to rise 1, 2, 3. That's going to be my rise. And my run is going to be -3. And you always want to simplify your slopes if you can. And in our case, we can, and that will simplify to -1. So my slope in this case is going to be -1. Now, one thing to mention about a slope, now, yes, we have 2 given coordinates on all of these graphs, but just remember, your slope is going to continue all the way up this line, going all the way off the coordinate plane in both directions. Okay, let's talk about this idea of a zero slope and a undefined slope. So zero slopes are, again, horizontal slopes, but let's just kind of see how they work. So if I look at my rise and my run of a zero slope, I'm going to go ahead and I'm going to start at this point, and then I'm going to make this point my destination. Okay, well, my rise. To get to that second point, I don't need to rise any, so my rise is going to be 0. And then to run to my point, I'm going to run 1, 2, 3, 4 spaces. So you can see that 0 divided by 4 is going to give me 0, which is going to give me my slope of 0. And that's how we're actually calculating the slope of 0. Now let's look at the other one. Let's go ahead and let's just start at this point, and we'll make this our target. So we want to rise first, so I'm going to rise 1, 2. And then I'm going to run while I'm not running, either left or right, so my run is 0. And you know that any number divided by 0 is going to be an undefined answer. And if you put that in your calculator, it'll say something like syntax error. The way I like to identify this is just UND. That's my slope, undefined. Okay, now we're going to look at this idea of slope and rate of change using coordinates. And as we continue to progress within Unit 4, you're going to start to see similarities and things that you can put together to and see the connections between them. So for right now, we're learning those essential skills. So let's determine the slope of a line between 2 points using the slope formula. So this is our new formula, the first one of Unit 4. And here is what the formula means. We know that m is our slope, and then we're going to have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, what those means are all of those points are x and y coordinates that you're given. Okay, let's go ahead and use the formula. Let me show you how this works. All right, my given coordinates are below in this first example. Here's what I'm going to do first. In my first coordinate, I'm going to label him x1 and y1. See where this is going? The next coordinate, I'm going to call it x2, y2. Yep, you got it. We're going to plug it in now. M is equal to. Now, I want to plug in my numbers. The first part of my formula is y sub 2, so I'm going to say -18. I'm going to substitute him right in there. All right, my formula says minus, so I'm going to subtract my y sub 1, which is -3. Now, careful here. I'm going to put in a -3, just like that. x2 is going to be a 3 minus my x1, which is 2. Okay, now that we're ready to go, we can simplify. -18 minus -3 is actually going to turn into a plus, right? That's going to give us -15. And 3 minus 2 is going to give us 1, and we want to simplify that down to -15. So, given 2 points, our slope is going to be -15. And if you're thinking, does this correspond onto a coordinate plane just like we talked about? And you're absolutely right, it sure does. All right, let's try another one. I'm going to go ahead and label them x1, y1, x2, y2. Now, if you wanted to call the second coordinate that you see here x1, y1, and you wanted to call the first coordinate x2, y2, that is perfectly fine. It does not matter what order you put them in. All right, let's go ahead and substitute them into our slope formula. So my y2, I'm going to grab that, and that's -12, minus, because that's part of my formula, y1, which is -18, divided by x2, that's -11, minus x1, which is 7. Okay, now you have to do a little bit of math here, but that's what you can do in your head, you can do in your calculator. Either one works. Looks like I get 6. And it looks like I get, what do I get? Negative 11 minus 7. Looks like that's negative 18. And then, of course, I can simplify that slope. That's actually going to be negative 1 over 3. So my slope in this case is negative 1 over 3. Okay. Now, I have two little situations here for you to just kind of think about. And especially, you look at your formula as you look through these. What happens when your x values are the same? So in our case here, I have x values that are identical. Well, look at the formula for just a moment. If you think about it, no matter what y2 and y1 are, it doesn't really matter because look at my x's. I'm going to have a 5 minus a 5, which is going to give me a 0 in the denominator. Anytime you have a 0 in the denominator, that's going to give you a slope that is undefined. Likewise, if I look at this one, I have a y, two y's that are identical. No matter what, my x2 and my x1, no matter what they are, my numerators are the same, which is going to give me a numerator of 0. And we know that when there's a numerator of 0, so 0 divided by anything, your slope is going to be 0. Okay, let's look at a couple more items. All right, let's look at this. Determine the missing value. Now we're going to look at slopes, and we're going to refresh our memories on this idea of proportions. So determine the value of x. So the line that passes through the point negative 2x and 6, 7 has a slope of 1/2. Here's how you set this up. All right, just like before, I'm going to label my coordinates. Grab my pen. I'm going to call him x1, y1, x2, y2. Since I have 2 points and I also have a slope, I can use the slope formula. So let's say m. Well, m, don't I know my m? I know that my m is 1/2. I'm going to set that equal to my slope formula. So if you remember your slope formula, feel free to scroll up, but you can see here's your slope formula. y2 minus y1 over x2 minus x1. Let's go ahead and write that down. y2 minus y1 over x2 minus x1. Be real careful with that negative there. All right, let's go ahead and simplify this. I have 1/2 equals 7 minus x over 8. Hopefully that it's looking very familiar to you. This is a proportion, so we're going to solve a proportion. So I have 8 times 1 is equal to 2 times 7 minus x. And of course, I'm going to go ahead and distribute there. And I'm going to go ahead and I'm going to subtract my 14. So it looks like x is equal to 3. So what does x actually mean? That's not the slope in our case. Actually, this x represents the y-coordinate of our first point. So what it's saying is a line with a slope of 1/2, well, it's going to go through both of these 2 points. And it's going to be negative 2, 3, and then 6, 7. Let's do one more like that, but with the other variable. Let's go ahead and label our coordinates in this example. We have x1, y1, x2, y2. And this time they're giving us a slope of 4. All right, let's set it up. 4. I could also write this as 4 over 1 if you like that more. And let's go ahead and put it into our formula. Negative 7 minus 9 over y minus negative 15. Go ahead and simplify. 4 over 1 is equal to negative 15. 16. There we go. 16. Divided by y plus 15. Don't know what's wrong with my pen here. Okay, now here we go. Let's go ahead and use our proportions technique, and let's go ahead and solve this. So I have 1 times negative 15 is equal to 4 times y plus 15. So I have negative 15 is equal to 4y plus 60. I'm going to go ahead and subtract 60. I have negative 75 equals 4y. And it looks like my y, hopefully if I did my math right here, is going to be negative 18.75. Yep. So that right there is my y coordinate. That is going to be the coordinate that is going in right there. And what's nice about this is it's not always going to be a beautiful integer coordinate. In our case, it is not. So, yeah. All right, let's look at the last. Oh, that is the last piece of this section on slope and rate of change.